Okay, so this is the 4.6a video. Number one, they want you to solve by finding or using square roots. So let's write down our original problem. 2x squared equals 32. So we want to isolate x if we can. So we divide by 2 as a first step. So we have x squared equals 16. So we take the square root of both sides. So we get x equals, when we take the square root and we're solving for x, we want to take both the positive and negative roots of it. So positive, negative 4. So you could write it in set notation as negative 4 and positive 4. Number two, solve the equation. So let's write it out. X squared plus 6x plus 9 equals 1. Before we do something like subtract 1 from both sides, it should occur to you, or it should be noticeable to you, that this trinomial on the left side is a perfect square trinomial. Because the square root of x squared is x, the square root of 9 is 3, and this term is double the product of the square root of the ends. So that's a perfect square trinomial. So we can write it as a perfect square trinomial. It's x plus 3 squared. Because this x goes here, the 3 goes here, and you take that sign. Because it's like that, now we can solve for x by isolating it. We can take the square root of both sides. So x plus 3 equals, we take the positive and negative roots of the square root of 1, so it's positive negative 1. Next step, we subtract 3 from both sides. So x equals positive or negative 1 minus 3. So for our solutions, we have either negative 1 minus 3, which is negative 4, or positive 1 minus 3, which is negative 2. Number 3, we want to complete the square. So to complete the square, we take half of this, which is 10, and then square it. So it's 100. X squared plus 20x plus 100. And if I wanted to factor this, that would be the same as x plus 10 squared. Number 4, solve by completing the square. So x squared minus 2x equals 5. The first step would have been to move the constant term over, but they already did that for you, so you don't have to do that. And what I mean is, if it was like this, the first term or the first step would be to move the 5 over, and then you get this. The next thing you should do is to factor out the lead coefficient, but the lead coefficient is 1, so we don't even have to do that. What we do now is we complete the square on the left-hand side. So we have this little space here, we just move it over. We take half of this term, that's negative 1, we square it, it becomes positive 1. So when I add 1 to this side, I have to add 1 to that side. This is now a perfect square trinomial. It's x minus 1 squared, and that's going to equal 6. When you go from a perfect square trinomial to a perfect square factorization, it always becomes a square root of this, you take this sign, and it's the square root of that. So let's take the square root of both sides, because we want to solve for x, and then we add the 1. Write down the 1 before the positive negative root, and that is your answer, 1 plus or minus root 6. Alright, number 5, we're going to do the same thing. We're going to complete the square to solve. So 9x squared minus 12x minus 2 equals 0. Our first step is to move the constant over. Then we factor out the lead coefficient. If I factor a 9 out of 12, I would get 12 ninths x. But for 12 ninths, 3 goes into them, into both 12 and 9. So we can reduce that. So all we did there was we factored out a 9 from both of these terms. And when I had said that when you factor a 9 out of 12, you get 12 ninths. But this can be reduced by a factor of 3. So if you divide the top and bottom by 3, you get 4/3. So now we leave a space in here. So we take half of this, which is 4/6 or 2/3. Because when you take half of 4/3, the 2 and the 4 cancel. So you get 2/3. So you take half of this and you square it. So I'm going to square 2/3. You get 4 ninths. So you put that inside here. Now we didn't just add 4 ninths in there. We actually added 9 times 4 ninths, which is, the 9's cancel, 4. We really added 4 on the left-hand side, so what we have to do is we have to add 4 on the right-hand side. Now we simplify. So now we have x minus 2/3 squared equals 6. And we got the 2/3 by taking either half of this, which is 2/3, or we just take the square root of this. And don't forget we use this sign. So now we divide both sides by 9. When I take 6 and divide it by 9, I get 2/3. Take the square root of both sides. And then we add 2/3 over. So x is going to equal positive negative root 2/3. Sorry, let me just move that. Whoops. Let me erase it then. X equals, we're going to put the 2/3 in front. 2/3 plus or minus the square root of 2/3. Eventually we're going to talk about how to simplify this here. But this will be fine for now. Alright, rewrite the equation in vertex form. So y equals 1/2 x squared minus 5x plus 12. First thing we're going to do is we're going to move the constant term over. So we have y minus 12 equals 1/2 x squared minus 5x. Next, we factor out the lead coefficient. So we're going to have x squared minus 10x. Because when you factor out a 1/2 from 5, it's like multiplying by 2. Because you're taking 5 and dividing it by a half. So we complete the square here. Half of negative 10 is negative 5. Negative 5 squared is 25. But we're not really adding 25. We're adding a half of 25. So we want to add 25 halves over here. So if I make negative 12 halves, it's going to be negative 24 halves. And if I add that to 25 halves, I get 1/2. So y plus 1/2 equals 1/2 parentheses. This is now a perfect square trinomial, x minus 5. This is the equation in vertex form, and they want you to find the vertex. So the vertex is going to be the opposite of what you see here, comma, the opposite of what you see here. So that's the vertex. Number 7, solve by factoring. So because the lead coefficient here is positive, and we're looking at the x squared term, we want to make that positive. So it is positive. So we're going to leave this term here. We're going to move these terms over to that side. So 3x squared minus 22x minus 16. So now we want to factor this. So it's not a perfect square trinomial. It's in order. The lead term's positive. So we have to use the box method. So the lead term here, 3x squared, the last term here, we're going to be dealing with 48. So 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. Different signs, the larger number's negative. These are all negative, these are all positive. Which one of these adds up to negative 22? That would be this one here. So we have 2x and negative 24x. So negative, negative, positive, positive. So those are the signs. Let's factor out here. We have an 8 as a factor. X, 3x, and 2. So 0 equals 3x plus 2 times x minus 8. Now we want to solve. So we have to take each of these factors and set them equal to 0. If you set 3x plus 2 equal to 0, you subtract 2, divide by 3, you get negative 2/3. If you set x minus 8 equal to 0, you add 8 over, you get x equals 8. So your solutions are negative 2/3 and 8. Alright, number 8, determine whether a quadratic model exists or not. So if we take a look at a graph of this, 0, 2 would be, let's say, right over here. 1, 0 is here. And 2, 4 would, let's say, be here. They're not collinear. So that means a quadratic model does exist. So let's get the calculator out. Let me just do this junk first. And here it is. Okay, so we're going to do stat 1 for edit. We're going to enter L1, so 0, 1, and 2. L2 is going to be 2, 0, and 4. We're going to hit stat again, go over to calc. It's a quad reg, so 5. Enter. So A is 3, B is negative 5, C is 2. So the model will be between negative 5 and 2. Just write this down quick. Okay, so f of x equals 3x squared minus 5x plus 2. And that's your model. Number 9. Alright, so this is another calculator problem. A ball's thrown from a height of 4 feet, and it travels along this equation here. So let's plot that by entering that equation. So negative x squared plus 4. Let's take a look at the graph. So it's thrown from a height of 4 feet. So this is where it's thrown. So it's going to be 4 feet high. And then the ball just drops. And it ends up right over here. How many feet away will the ball land? So we need to find this 0. So we do second trace 2. The left bound is going to be anywhere before that. Enter. Right bound anywhere after it. And then guess. So it's going to be 2. 2 units or 2 feet away. Number 10. Explain why word problems such as the one we just did involving throwing an object along a parabola have equations with the lead coefficient that's negative. Well, if you can picture in your mind what a parabola looks like if it's negative, it means it opens down, right? So when you throw a ball, it has to have this trajectory, meaning going down. It's not going to go up like this. And the reason why is because gravity is taken into account. When you throw a ball, it's going to fall down to the ground because of gravity. So it has a lead coefficient that's negative because the flight path has to open down because of gravity. And parabolas that have a lead coefficient of a negative, meaning A is negative, are parabolas that open down. And that's the reason.